Did you sit out on the table?
Are the periodic table, and they're all made up of certain molecules and atoms. And many atoms and molecules.
Yeah, it's a lot easier on the table.
And you're going to write down two things after you write the titles up on the board, Andrew.
Yeah.
How do you have the title written already? Is it on one line?
Yes.
Is it big enough for me to see? Is it dark enough for me to see?
Yeah.
Dear Tim and Moby, what in the world are atoms? Chris, what in the world isn't an atom? Air, water, ants, leaves, robots, and humans are all made up of atoms. This is the periodic table of elements, and when you take chemistry, it becomes your best friend. This chart shows and predicts every known element in the universe: oxygen, iron, lead, and so on. These elements are all made of atoms. Around 2,400 years ago, a Greek guy named Democritus argued that everything in the world was made up of particles so small they could not be cut in half. He called these tiny things atoms, from the Greek word atomos, which means indivisible. In the 1800s, another guy named John Dalton refined the idea with his theory that atoms are the smallest particle of an element that retains its chemical properties. That means if you break apart an atom of an element like carbon, it's not carbon anymore. What is it? Well, atoms are made up of even tinier subatomic particles called protons, neutrons, and electrons. The atom's center, or nucleus, is a cluster of protons and neutrons. Protons have a positive electrical charge, and neutrons have no electrical charge. The atom's nucleus is held together by a strong force, which keeps the positively charged protons from repelling each other. The nucleus is surrounded by a cloud of electrons moving near the speed of light. The electrons have a negative charge that attracts them to the protons, and they live in shells representing different energy levels. On the periodic table, atoms are organized by their atomic number, which is really their number of protons, or electrons. You can also find the atomic mass here, as well as the element's symbol. I kind of think it's amazing that the difference of a few little protons, electrons, and neutrons can produce such a variety of elements with completely different properties. Different types of atoms can bond together to make molecules. Water is a molecule. It's two atoms of hydrogen and one atom of oxygen, or H2O for short. You would not believe how small atoms are. It would take nearly 10 million atoms just to cross this dot. And the scale of the atom itself is even more ridiculous. If the nucleus was the size of an apple, the electrons would be 5 whole football fields away. Ow! That means all matter in the universe is mostly made up of empty space, which frankly blows my mind.
Okay, that's a very brief one, and we're not going to go into an explanation. I would have had 2 facts down. 1, atoms make up everything. 2, it would take 10 million atoms to go across this dot. That's how tiny they are. Okay? Yes?
We also have
And we also have the periodic table right here. So, what we're going to do is, you remember the rule when we go and see a machine? Do you have your drawing also? Is this it? So we're going to take that out. And show that. Is this yours too? Should I put this in there? Okay, everyone, I want you to rows 4 and row 1. Would you come back here and stay 3 feet away from the
Chamber
table?
copper.
They were going to do mine next.
Row. I think I already called row 4. Row 5
Yeah, you
and row 2. Don't even come closer. You can stand over here by Mrs. Quo. Does everyone know Mrs. Quo? Okay. Okay, stand way back. Do not even come close to the table. over this way. Way back, way back. So you're going to stand a little farther back. And before Aaron even starts this, I'm going to have him talk about it. He's going to show you his diagram and his transfers of energy. Okay, the other rows, come back, please. Walking. Come over here, Caitlin.
Put the marble in and
Wait a minute, wait till they're all here, Aaron. Oh, be careful, Catherine.
so I'm going to put the marble in.
Well, tell us about the machine first. Tell us what is this machine? What does it do?
So
Shh, come on up
it's
here. Come here.
going to hit the pins.
Okay, so a marble is going to eventually hit the pins, or the roller is going to eventually hit the pins?
The roller.
Okay, so this is a bowling machine?
Yeah.
Okay, and now you can tell us about each transfer.
Okay, I put the marble in, and this track goes down, and the
Why does the track go down, Aaron?
because there's too much weight here.
Weight. Okay, so weight brings it down.
Yeah, and
Comes a lever.
This guy goes down and hits the dominoes, and it hits the tape, and
No one
hits
touched
the
it.
How did you know how far back to put this? Did you have to measure it, or you just know that all the dominoes start underneath the bucket? How did you measure?
Like this is 1 foot.
Okay, so you did quantify it. You quantify by measuring. So he knew when he set this up, he didn't just go, oh, well, I think that's okay. That's close enough. The more you measure and check and draw where things need to be, and then looking at, he also probably had to pay attention to how far apart his dominoes were. And then you have almost a foot to the pins, about 10 inches probably.
Well, yeah.
Okay. Okay, Santa, you don't want to be touching the table. So this is your armature to get it up high enough for what? For gravity? Stay where you were. Stay back where you were.
So this can tip over,
Okay.
and so
Right.
this guy.
Okay, would you show them? You did a beautiful diagram. And I'm going to have some of you redo your diagram. Can I hold it up here? I'm going to have some of you redo your diagram because I need to clearly see where your letters are. And he even did it in color as well. Did you also write it on a piece of paper yet? So what we're going to, yes, can I have that as well, Aaron? So then he takes the A, B, and C and writes each one out as a sentence about what happens. A, the cup, and he wrote it in complete sentences. Put the marble in the cup. That's A. B, the cup pushes the lever down. Are those complete sentences?
Yeah.
So many of you gave me rough drafts, but you didn't give me final copies. These are final copies. Can you lay those on the table? And I want those when you're finished.
It's not doing
We'll see. Okay.
like
You ready to go, Aaron? Wow!
One domino survived.
That is
One
so
domino.
great. Did you get that on tape, Mom?
Yes.
Thank goodness. Because if you get that on tape and you can,
YouTube.
I don't know, can you YouTube it and then send it to me?
Video.
You can, what?
There's a flip video that Aaron.
That flip video also does it automatically.
The roller was pushing one bowling pin.
Aaron, how long did it take you to finally get it to the way you wanted it to be? Was it 5 minutes? Was it 2 hours? Was it over a period of days that you played with it?
Was it a week?
Let him.
I thought of it like for 3 weeks, and I did it in 1 day.
So you took a day, so you've been thinking about it, you've been planning it, and then did you get the materials that you needed right away?
No,
Did it take a while to get your materials?
yeah, the box.
See, so it takes some planning time, doesn't it, to do this well? Yes.
I needed to buy 2 cars to,
Did you have to, so you had to, well, that's okay. We'll let you buy, as long as they're not real cars.
I
It's a
know,
little expensive.
2 toy.
Okay, can we have another round of applause? Okay, go back to your seats while Erin cleans up, and Erin, I want those to keep your machine here, because we have like a little, we have a one big science fair underneath this. Is your name on this? Your seats, I like the name. Wow, successful on the first try, Erin.
He did several tests at home.
What?
He did several tests at home before he broke.
Because they usually, you know, a lot of times they don't.
He was actually ready last Thursday, but he said, no, I wanted to do
He wanted to get
more."
him. See, that's good. High five to you, Aaron.
Should I do? Can I do mine?
No,
Can we do our machine?